All right, let's talk about something we all use every single second of the day, but probably don't think about too much. It's this invisible network all around us. It's in our homes, our favorite coffee shops, pretty much everywhere. We just call it Wi-Fi, right? Well, today we're going to pull back the curtain and see how all that magic actually happens. I mean, really, just stop and think about it for a second. You tap on your phone and boom, a video starts playing, a message sends, a whole website just appears out of nowhere. How? How does your request get from your device out into the world and back again without a single wire in sight? That's the big mystery we're going to solve. So, the fancy technical term for what we call Wi-Fi is a wireless local area network, or WLAN for short. But you know the most important part of this whole definition, the real key, is that little phrase at the end, augmenting a wired network. See, Wi-Fi wasn't really meant to replace all cables everywhere. It's more like this amazing add-on that gives us freedom and flexibility. So here's our game plan. We'll start with why going wireless is such a huge advantage. Then we'll get into the two main ways our devices actually talk to each other. After that, we'll look at the official rulebook that makes it all work together. And finally, we'll see the super clever system that keeps all these signals from becoming a chaotic mess. So why did we all jump on the wireless train so fast? I mean, it's not just about being convenient. There are some really powerful, really practical reasons that made WLANs a total game changer for, well, everyone. And those reasons are pretty compelling. First, the big one, mobility. That whole anywhere, anytime idea. But it goes deeper. It's also way cheaper and faster to set up. Just think about it, right? No drilling holes in walls, no fishing cables through the ceiling. You just plug in a router and configure it. This means we can get a network into places where wires just can't go, and adding a new person or a new device is unbelievably simple. Okay, so here's something you might not know. Not all wireless connections are built the same. Turns out, depending on what you're trying to do, your devices will connect in one of two totally different ways. Let's break them down. So the first way, and by far the most common, is infrastructure mode. I call this the coffee shop method. When you're at a cafe, your phone isn't talking directly to your friend's laptop across the table. Nope. Both of your devices are actually talking to a middleman, that little box with the blinking lights in the corner. That box is the access point, or AP, and its job is to play traffic cop for everyone. And then there's the second way, ad hoc mode. You can think of this as the direct method. With this one, you just cut out the middleman entirely. The devices talk straight to each other, peer to peer. The perfect example? Using something like AirDrop to send a photo from one phone to another. An ad hoc network is created instantly just for that one job, and then it disappears. So each one has its own superpowers, right? Infrastructure mode is amazing for big spaces, like an office, because you can easily expand your network and let people walk around or roam without dropping the connection. Ad hoc, on the other hand, is your go-to for a quick, temporary link. It's super fast to set up, it's cheap because you don't need to buy a router, and sometimes it's even faster since the data is going straight from A to B. Now, how is it that a device made by Apple can talk to a device from Samsung on a network run by Google without any problems? It's because they all follow the exact same set of rules. And in the world of Wi-Fi, that official rulebook comes from the Institute of Electrical and Electronics Engineers, and it's called IEEE 802.11. The story really kicks off back in 1985. The US government basically set aside a small piece of the radio airwaves and said, hey, anyone can use this, no license needed. That was a huge deal. Fast forward to 1997, and we get the very first 802.11 standard, giving us a mind-blowing 2 megabits per second. To put that in perspective, that's barely enough to stream a song today, let alone a movie. Of course, it's evolved like crazy since then, getting faster and more powerful with every update, making all the things we do online today even possible. And that original idea, that Wi-Fi is a partner to the wired network, is so important that the networking giants like Cisco still talk about it. Even with all the insane speeds we have now, Wi-Fi's main job is still to be the flexible, mobile front end for the super stable, high-speed wired network that really forms the backbone of the internet. Now, before radio-based Wi-Fi became the king, there was another technology in the running. Infrared. Yeah, like your TV remote. Infrared networks were simple, cheap, and they couldn't be messed with by other electrical noise. But they had one massive flaw. You needed a clear line of sight. The signal couldn't go through walls. In the end, radio won out for one simple reason. It could go through walls. That ability to cover a whole house was worth the small risk of interference. Okay, so you have all these different devices in all these different houses and apartments, all shouting into the air at the same time. How is it not just complete and utter chaos? Well, the answer is a really, really smart system of organization. It all starts with the most basic piece of the puzzle, something called a basic service set, or a BSS. The easiest way to think about it is as a single cell. A BSS is just one access point, one router, and all the phones, laptops, and tablets connected to it. Your Wi-Fi network at home? That's one BSS. So, how do you scale up from that one little cell to cover an entire office building or a university campus? It's like using building blocks. You start with your first BSS. To make the network bigger, you add more BSSs and link them all together. That creates what we call an extended service set, or ESS. And then, for the final step, you plug that whole wireless system into the wired network, which is its gateway to the rest of the internet. But that brings up the big question. If you have all these cells right next to each other, how do you keep them from yelling over each other? The solution is just beautifully simple. You put them on different channels. The best way to picture it is a highway. You wouldn't have all the cars trying to drive in the exact same lane, right? You'd have a traffic jam. Instead, you create separate lanes to keep everything moving. Wi-Fi does the exact same thing with your data. And to make that highway idea more real, a very common Wi-Fi standard has about 13 of these lanes or channels available. Now here's the clever part. Some of those lanes actually overlap a little. So the pros who set up big networks use a specific trick. They pick channels that are far apart from each other, like channels 1, 6, and 11. Because those three don't overlap at all, you can put routers using them right next to each other and get a perfect, crystal clear signal for everybody. All right, so let's boil all of that down. What are the big things to remember? 1, wireless networks are all about giving us flexibility and mobility. 2, they work in 2 main ways: infrastructure mode with a router and ad hoc mode for direct connections. 3, none of it would work if every company didn't follow the same rulebook, the IEEE 802.11 standard. And finally, the whole thing stays organized by using different channels, just like cars in different lanes on a highway. And you know that rulebook, that 802.11 standard, is a living document. It's always being updated and rewritten to give us more speed, handle more devices, and be more reliable. It really makes you wonder, as our world gets more and more connected, what amazing things will the next chapter in the Wi-Fi story make possible?